Uh, Example 2, find the LCM and HCF of the 6 and 20 by the prime factorization method. Solution, we have 6 is equal to 2 for 1 into 3 for 1, and 20 is equal to 2 into 2 into 2, 2 into 2 into 5, okay, equal to 2 for 2 into 5 for 1. You can find HCF of 6 comma 20 and LCM of 6 comma 20 is equal to 2 into 2 into 3 into 5 is equal to 60, as shown down in your early classes. Note that HCF of 6 comma 20 is equal to 2 for 1. Product of the smallest power of the each common prime factor in the number. Product of smallest power of each common prime factor in the number. Small product of the small power of each common prime factor in the numbers. Okay. Product of the smallest power of each common prime factor in the number. LCM 6 comma 20 is equal to 2 for 2 into 3 for 1 into 5 for 1 is equal to product of the greatest power of the each prime factor involved in the number. Okay. Product of the greatest power of each prime factor involved in the number. Note 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 for any two positive integers a comma b, for any two positive integers a comma b, highest common factor HCF of a comma b into LCM of a comma b is equal to a into b. HCF a comma b into LCM of a comma b is equal to a into b. Okay. Find the HCF of 96 and 404 by the prime factorization method and find their LCM. Find the HCF of 96 and 404 by the prime factorization method and find their LCM. The prime factorization of 96 and 404 gives 96 is equal to 2 for 5 into 3 and 404 is equal to 4 2 into 101. 96 is equal to 4 5 into 3 and 404 is equal to 2 for 2 is into 101. Therefore, the HCF of these two integers is 2 for 2 is equal to 4. The highest common factor of these two integers is 4. Also, LCM of 96, 404 is equal to 96 into 404 by HCF of n 96 in 96, 4, 4. Okay, again LCM of 96, 404 is equal to 96 into 404 by highest common factor of 96, 404 by formula HCF of a comma b is into LCM of a comma b is equal to a into b. So here LCM into HCF is equal to a comma a into b. Okay, again LCM into HCF is equal to a into b. Okay, a into b. LCM into HCF is equal to a into b. Okay, write the set x such that x is a positive integer and x square less than 40 in the roster form. The required numbers are 1, 2, 3, 4, 5, 6, and so on. The given set in the roster form is open braces 1, 2, 3, 4, 5, 6, closed brace. Okay. Write the set A is equal to open braces 1, 4, 9, 16, 25, so on is set pillar form. Solution: we may write the set A as A is equal to open braces x such that x is the square of the natural number. Alternatively, we can write A is equal to x such that x is equal to n square, where n belongs to n. Okay, A is equal to open braces x such that x is equal to n square, where n belongs to n. Example 4, write the set open brace 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, 6 by 7 in the set pillar form. We see that each member in the given set has the numerator 1 less than the denominator. Also, the numerator begins from 1 and do not exceed 6. Hence, in the set pillar form, the given set is open brace x such that x is equal to n by n plus 1, where n is the natural number and 1 less than or equal to n less than or equal to 6. Definition: a set which does not contain any elements is called the empty set or the null set or the void set. Okay. A set which does not containing any elements is called the empty set or the null set or the void set. According to this definition, B is an empty set while A is not empty set. The empty set is denoted by the symbol phi or open bracket, open braces, closed braces. A set which is going to consist of a definite number of elements is called finite. Otherwise, the set is called infinite. Consider for example, set W be the set of the day of the week. Then W is finite. Let S be the set of solution of the equation x square minus 16 is equal to 0. Then S is finite. Let G be the set of the points on the line. Let G be the set of points on the line, then G is infinite. Equal sets. Two sets A and B are said to be equal if they have exactly the same elements, and we write A is equal to B. Otherwise, the sets are said to be unequal, and we write A not equal to B. Again, two sets A and B are said to be equal if they have exactly the same elements, and we write A is equal to B. Otherwise, the sets are said to be unequal, and we write A not is equal to B. Okay. Example, we consider the following. The example, let A is equal to open brace A comma A is equal to open brace A 1 comma 2 comma 3 comma 4, and B is equal to open brace 3 comma 1 comma 4 comma 2. Then A is equal to B. Find the pair of the equal sets if any given reason. Example 7, find the pair of equal sets. Pair of equal set if any given reason. A is equal to open braces 0 closed braces. B is equal to x such that x greater than 15 and x is less than 5. C is equal to x such that x minus 5 is equal to 0. D is equal to x such that x square is equal to 25. E is equal to x such that x is an integer positive root of the equation x square minus 2x minus 15 is equal to 0. Solution, since x belongs to A and 0 does not belongs to any of the sets B, C, D, E, it follows that A not equal to B, and A not equal to C, and A not equal to D, and A not equal to E. Since B equal to 5, but 5 means empty set. B is equal to 5 empty set, but none of the other sets are empty. Therefore, B not equal to C, B not equal to D, and B not equal to E. Also, C is equal to 5, but minus 5 belongs to D. Answer, C not equal to D. Since E is equal to 5, C is equal to E. For the D is equal to open brace minus 5 comma 5, and E is equal to open braces 5, we find that D not equal to E. The other only pair of the equation sets is C and E. Okay. Okay. Example 8. Which of the following pair of sets are equal? Or justify your answer. First, X, the set of the letters in alloy, ALL, O, Y, and B, the set of letters in loyal, LOYAL. Second, A is equal to open base n such that n belongs to Z and n square less than 4, and B is equal to X such that X belongs to R and X square minus 3X plus 2 is equal to 0. Solution. First, we have X is equal to A comma L comma L comma O comma Y. B is equal to L comma O comma Y comma A comma L. Then X and B are equal sets or repetition of the elements in do not change a set. Thus, X is equal to A comma L comma O comma Y is equal to B. Second, A is equal to minus 2 minus 1 0 comma 1 comma 2. B is equal to 1 comma 2 since 0 belongs to A and 0 not belongs to B. A and B are not equal sets. Definition. A set. A is said to be subset of a set B if every element of A is also an element of B. In order the what A subset of B, if anywhere A belongs to A, then A belongs to B. It is often convenient to use the symbol implies, which means implies. Using this symbol, we can write the definition of subset as following. A subset of B if A belongs to A implies that A belongs to B. Example 9, consider the set pi comma A is equal to 1 comma 3, B is equal to 1 comma pi comma 9, C is equal to open braces 1 comma 3 comma pi comma 7 comma 9 closed braces. Insert the symbol belongs to or not belongs to between each of the following pair of sets. First, pi B 2 A dash B, 3 A dash C, 4 B dash C. Solution. Solution. Pi belongs to B. Pi is a subset of every set. Second, A not belongs to B as 3 belongs to A and B belongs to B. 3 A subset of C as A comma B, 1 comma 3 belongs to A also belongs to C. Fourth, B belongs to C as the element of B is also element of C.